Well wishes friends, now it's time to study the equations of motion. Okay, uh, as you know, these are the 5 different equations which we have to learn, we have to use everywhere in physics. So now we shall derive these equations one by one, and the good thing is that the all the derivations are not possible because few of these equations are coming by mathematics and few of these equations are coming by the concept. Say for example, equation number A. Okay, it is about acceleration v minus u upon t. How do we define acceleration? We define acceleration as rate of change of velocity or rate of change of speed. Okay, now what is change in speed? How do you calculate the change in speed? You calculate the change in speed like this. It is final speed minus initial speed. This is what? This is change in speed. And when I say rate of change of speed, it is supposed to be divided with time. So this is what? This is rate of change of speed, which is defined as acceleration. Okay, there is no need to derive this because it is directly coming from a definition. Okay, so first equation, no need to worry how this first equation is derived. In the same way, equation number D, that is for average velocity or average speed. It's again very simple. What is average speed defined as? Average speed is defined, basically it is defined as total distance covered to the total time taken. Okay, S is the total distance covered by the body and T is the time taken to cover that distance. This is how we define average velocity. Plus by mathematics comes one more formula to find the average of anything. What do? Is we just add those numbers and divide by 2. If there are 3 different velocities, then what you have to do? You have to take 3 additions and then divide by the number 3. So for A and D, there are no derivations that are required. Okay. Now coming to the other derivations, say the derivation of v square minus u square is equals to 2as. Okay, so what do? We do this. It's v square minus u square. First step is to factorize this. V minus u, v plus u. Easy factorization. Now, v minus u. What is v minus u? Consider this. V minus u upon t is equals to a. So what is v minus u? V minus u is equals to at. See, v minus u is equals to at. And what is v plus u? Take from here. See, v plus u by 2 is equals to average speed. So v plus u is equals to 2. 2 goes over here. Okay, this 2 moves over here, and this gives us this thing, 2AV. Okay, so this is AT plus 2AV. Again, now rearranging these things, 2 and A are kept on one side, average velocity and time are taken into the bracket. What is average velocity? See, average velocity is equals to distance over time. So velocity into time becomes equal to distance. Vt equals to s. Substitute this. V into t, whatever in the bracket, that is equals to what? S. So this is a very easy derivation. V square minus u square is equals to 2as. Next one, next derivation, we start from this point. Average velocity is defined as total distance upon total time and also defined as v plus u upon 2. So what are we going to do now? We are going to first transpose the t on the other side. T was it in denominator, it comes now in numerator. Okay, the first step. Second step, v inside the bracket in the numerator, what do you see? V plus u by 2. So what is v actually? We again go for a substitution of v and write v is equals to u plus at. See that? Okay. The second term u remains as it is, and of course there is a denominator 2 over here. Now what does this become in the next step? U and u becomes 2u plus at by 2 into t. Simple one, only u and u. They are added to become 2u. Okay. Now in the next step, we are going to, whatever quantity is inside the bracket, we are going to split it. And after splitting, what do you get? The 2 and 2 will be cancelled, and 2 will be taken as the denominator of at. Okay. And the last step, it's very easy to understand, ut plus half at square. What I have done, just to open the bracket. So this is again the derivation of this thing, that s is equals to ut plus half at square. This is the algebraic method of derivation. These formulas can also be derived by many other methods. We will discuss those methods later on, but this lecture only these algebraic methods of derivation. Now coming to the mysterious equation. What is the mysterious equation? This one, equation E, Sn is equals to u plus an minus half. What is this equation all about? This equation is all about this thing. Say we start with an example. S1 equals to 10 meters. This means that the S, distance covered by a body in 1 second, is 10 meter. Distance covered by the body in 2 seconds is 15 meter. Distance covered by body in 3 seconds is 17 meter. Now look at the data, and on the basis of data, try to answer this question, that what is the distance covered by the body in 3 seconds? The answer is 17 meters. Now tell me, what is the distance covered by the body in the 3rd second? Mind well, the previous question was that what is the distance covered by the body in 3 seconds, and now the question is what is the distance covered by the body in the 3rd second? Can you give the answer? Okay, if your answer is 2, it's easy, it's correct. Okay, now again I am asking you, what is the distance covered by the body in 4 seconds? The answer is 20 meters. And now if I ask you, what is the distance covered by the body in 4th second? The answer is, if you say it is 3 meters, you are correct. Again for the last time, what is the distance covered by the body in 5 seconds? It is 24 meters. And what is the distance covered by the body in 5th second only? The answer is, and this time you are correct, it is 4 meters. So what actually you are doing? You are subtracting. If I ask you, how do you find the distance covered by the body in 5th second? So for that, what you did in your mind? You did this. Distance covered by the body in 5 seconds minus the distance covered by the body in 4 seconds. That will give you 24 minus 20, that is equals to 4. So this is what you are actually doing in the mind. So to find the distance covered by the body in 3rd second, what you have to do? Total distance in 3 seconds minus total distance in 2 seconds. If I ask you what is the distance covered by the body in 4th second, then what do? You subtract S4 minus S3. That is this. The meaning of the distance, Snth, that is distance covered in nth second. Got it now? Okay. Now, how do we derive this formula? It has a little bit algebra involved in it. So very first thing, this is what is our concept. Okay. Snth. What is Snth? It is distance covered by n seconds, distance covered in n seconds minus distance covered in n minus 1 seconds. Okay, such as if you want to find the distance covered in 4th second, it is what? Distance covered in 4 seconds minus distance covered in 3 seconds. Same way, Snth is equals to Sn minus Sn minus 1. Now, again what we do is, we substitute equation B in both these equations. Remember equation B, S is equals to ut plus half at square. Okay, so we are going to substitute this value of x both for Sn and Sn minus 1, which gives me this broad result. Okay, Sn plus half an square minus, again in place of t you have to put n minus 1. Okay, and t square will be n minus 1 square. The rest is next step, the algebraic expansion of these. This is the algebraic expansion. Okay, I'm not going to do anything inside outside the bracket. Whatever I'm doing in the square brackets. So just opening this, n minus 1 square, you already know it is n square plus n square plus 1 minus 2n, a minus b whole square is equals to a square plus b square minus 2ab. Same with this expansion. The next step, open the brackets, go for a simplification. Again in the next step, open this bracket. You have to do it carefully. Maths requires a lot of attention, a lot of care. Otherwise a small mistake of sign can ruin your answers. Okay, now in this term there are cancellations. You can see un cancels with minus un, half an square cancels with minus half an square, and these are the terms that remain. U plus an minus half a. The last step is the concluding step. That is u taking a common. This is how the actual derivation goes. This is what we have actually derived. Okay, remember what is this? This is the distance covered by the body in n second. You must first understand the concept, that what it actually we are trying to find out, and then you find out this mathematically. But first understanding this concept, this one, this is very important, because what physics is this, the rest is mathematics. Clear with this? So these are the three equations of motion which we have derived today. Okay, that is enough for today. We will be deriving these equations on the graphical basis also, and later when we learn calculus, then we will derive these equations on the calculus basis also. That is all for today. Thank you.